Here we go on part 2 of this review guide for logic. So on this one, we are doing counterexamples, some converses in order to do biconditionals, and that's it. So this was like day 2 of our lesson with biconditionals and counterexamples. So here we go. To start with, it says decide if each statement is true or false. If it is false, provide a counterexample. So if x is an even number, then x plus 1 is an odd number. So it's saying if you have an even number like 2, 4, 6, 8, etc., if you add 1 to it, does it have to be odd? So, 1 more than this is 3, 1 more than this is 5, that would be 7, that'd be 9. So it looks like every single time if you add 1 from an even number, you get an odd number. So that one's true. Woohoo! Good thing about true is that we don't need to write the counterexample. Number 25. If a number is divisible by 3, then it is odd. So divisible by 3. I know 3, 6, 9, 12, 15. Those numbers are divisible by 3. So it's saying if it's one of these numbers, then it is odd. So if you look at them, you can already see some counterexamples. I'm just going to write the number 6. So false because of 6. 6 is a number divisible by 3, but it is not odd. So that's false. I just gave a counterexample. 6, 3 goes into 6, but it's not odd. For number 26, if you use social media, then you have a Twitter account. So if you use social media, do you have to have a Twitter account? Or are there other types of accounts? And that once again is false. Because could have only MySpace. Just kidding, you guys don't know what that is. Facebook. Yeah, maybe someone just Facebook. They don't do Twitter? Tweeting, that's the word. They could have only Facebook. So they're using social media, but not a Twitter account. Counterexample. Ta-da! For each of the following statements, write its converse. After writing its converse, say if the converse is true, then write it as a biconditional. If it's false, then do a counterexample. So no matter what in these ones, you are writing the converse. That's just a given. We are going to write its converse. So if the sun is shining, then it's 12 o'clock noon. So remember, what we're doing is we are switching. Converse, inverse, contrapositive, switch, negate, switch, and negate. Switch. So I'm going to switch these two things. So I write if, and then I switch these two. So I'll write it is 12 o'clock noon. Then this other one, the sun is shining. Oops. So let's see. If it's noon, then the sun is shining. That's true. If the sun is shining, then it's 12 o'clock noon. Well, I mean, there's a couple of things you could say for counterexamples, like if it's 12 o'clock noon and then the sun is shining, like, well, what if it was raining? So I could put something like, what if it's cloudy? If I can spell cloud, my goodness, cloudy. Cloudy, that would be a counterexample. If it's cloudy, then it could be 12 o'clock noon, but it's not shining. Or what if it was 11:59 a.m.? At 11:59 a.m., maybe the sun is shining. Either of these would be a counterexample because either one of them says that it's not true going forward and backward. So the sun is shining, then it's 12. Well, maybe not because it's cloudy. If it's 12 o'clock noon, then the sun is shining. Well, it doesn't have to be 12 o'clock noon. It could be some other time and still shining. Because at the biconditional, you would have to put if and only if. Like the sun is shining if and only if it's 12 o'clock noon. Which does not make sense. So next up, if the number is divisible by 3, then the number is odd. I think we already talked about this, but, you know, either way, it does say to do the converse, so here we go with that. Boop. Boop. We're going to tweak these. We're going to switch them. So if a number is odd, and I am saying a number instead of the number because that makes more sense. If a number is odd, then the number is divisible by 3. So if a number is odd, it's divisible by 3. Well, that already is false because of like 7. That would be a counterexample. 7. If a number is odd, like 7, then it's divisible by 3. But 3 does not go into 7. So that's false. False. And 7 is my counterexample. But also originally, if the number is divisible by 3, then it's an odd number. We already said that was false above with the number 6, right? So we already knew that was false. Okay, if an angle is 90 degrees, then it's a right angle. Yeah, that's like the definition. So this one should be easy peasy, lemon squeezy. We'll take those two things and we'll switch them for converse. So if it is a right angle, so if an angle is a right angle, then it is 90 degrees. Boom. All right. So I didn't write, word for word verbatim what it is, but it's the same thought. If an angle is 90 degrees, it's a right angle. So if an angle is a right angle, then it's 90 degrees. It's not the same words, but it's the same idea, and that's the thing that matters most. Let's see. If an angle is 90, it's a right angle. That's true. If an angle is a right angle, then it's 90 degrees. That's also true. So this is true, which means I have to write it as a biconditional, which means I shouldn't have written true right there. I should have written the biconditional. So I'll just do it below. What you do is you get rid of the word if, and then you replace the word then with if and only if. So replace the word then with if and only if. And I'm going to write this as a sentence. An angle is 90 degrees if and only if it is a right angle. Boom. All right, so we chop this off. An angle is 90 degrees if and only if it is a right angle. An angle is 90 degrees if and only if it is a right angle. So this replaces the then part. There you go. Write each definition as a biconditional. Oh boy. As triangle, maybe a triangle. A triangle that is isosceles has at least 2 congruent sides. So we just basically have to find a place to put the if and only if that makes sense. So a triangle that is isosceles has at least 2 congruents. How about we say like a triangle is isosceles if and only if. Let's see, it has at least 2 congruent sides. There we go. So it's triangle, an isosceles triangle, 2 congruent sides. So a triangle is isosceles if and only if it has at least two congruent sides. There we go. A cube is three-dimensional solid with 6 square faces. So a cube is a three-dimensional solid with 6 square faces. So those are the two thoughts going on. Just like here, this is kind of like where the two thoughts separated. You need to separate it so you know what's going to be like a hypothesis versus a conclusion. So here we would start with a cube is three-dimensional solid. So there's actually two ways to think about it now that I come to think of it. You can think about it as the cube is a three-dimensional solid, and then it has to have 6 square faces. But there is a case to be made where if you want to stop it right here, something is a cube if and only if it is a three-dimensional solid with 6 faces. I'll write them both. So like, a figure is a cube if and only if it is a three-dimensional solid with 6 square faces. So you could do that if you're separating it here, right? You could also say something like a three-dimensional solid is called a cube if and only if it has 6 square faces. There you go. So that's another thing that it could be like. Either way, it is having this thing with a cube and this thing with 6 square faces going on. And there you go. That is writing a definition as a biconditional. So hopefully this is helping. I'll zoom out so you can see the whole page in one go. And there you go. Okay, one more video to go. Peace.